Hello everyone, welcome back to my YouTube channel. This is MJ School of Mining and Geology. In today's lesson, we're going to be dealing with plane polarized light and cross polarized light in mineral optics. So don't forget to like, share, comment and subscribe to our YouTube channel so that we keep producing this kind of a content. So for you to understand the PPL and XPL, you need to understand why light is important in microscope. So we know light is part of the electromagnetic spectrum, which ranges from radio waves all the way to gamma rays. So now, but we're interested more in what you call the visible light. All right. So visible light is what a human eye can be able to see. So light is very important for all these characteristics: illumination, resolution, contrast, visualization, photography and imaging, non-destructive analysis and versatility. So in terms of versatility, light microscopy is a versatile technique that can be adapted to various research needs and applications. But now for non-destructive analysis, this is very important, especially for biology and material sciences. Okay, so this is because the researchers in these fields, they need to study samples in their native state. All right, so now the light microscopy in this case, it will be a non-destructive technique that will enable the examination of specimens without altering their integrity or composition. Now, but we don't have to forget that light microscopy enables the capture of images and videos of microscopic specimen for documentation, analysis, and also not only that, but also for communication purposes. So digital imaging system integrated with microscopes will allow for the acquisition of high quality images, which can be processed, analyzed, and shared with others. Now, but for example, the resolution, light is fundamental for achieving high resolution in microscope. That one is a fact. And then for the contrast, the light can be manipulated to enhance contrast in microscopy. Now, by so doing, you're going to be making it easier to distinguish features and structures within a specimen. Now, the most important part is illumination. This is because light serves as the source of illumination in microscopes, allowing specimens to be visualized by providing the necessary brightness for observation. Now, what is plane polarized light? Plane polarized light, it's nothing but a light produced if we put one polarizer. Okay, so now we know that natural light vibrates in all directions. So it vibrates or oscillates in all directions. As you can see over here, it oscillates in all directions. So this is the natural light. All right, so it oscillates in all directions. So if it oscillates in all directions, we're gonna now put the polarizer here. We put a polarizer here. Now this polarizer, it only allows the light that vibrates in north-south direction. It only allows the light that vibrates in the north-south direction. So by so doing, it means only light that vibrates in north-south direction will be able to pass through, and then they're gonna be seen when you are looking down your eyepiece in your microscopes. All right, so it means now the plane polarized light, they have one plane of vibration. You can see they've got one plane of vibration, okay, which is north-south plane of vibration. Okay, so in which now the direction of vibration is always perpendicular to the direction of propagation. Now the propagation, it's in this direction, but now this the direction of vibration, it's perpendicular to the direction of propagation. So basically now, which is why in plane polarized light you are able to see the color, all right, because of your eye or your eyes are able to see that a particular color. It's because of the help of visible light. But now, this is different from cross-polarized light. Now, with cross-polarized light, you are placing two polarizers, but when you place them, you make sure that they are crossed, that they are perpendicular to each other. Now, the unpolarized light, it will be vibrating in all directions until it means the first polarizer, the bottom nickel or bottom polarizer, which is always there. You can't insert or remove it. It's always there. So now if for instance it's vibrating, the plane it's in the north-south direction, now it will only allow the light that are propagating in the north-south direction. Now the second polarizer, which is now crossed, it will allow only, it will block that light that was passing, which passed the first polarizer, which was in the north-south direction. Now, because we placed this in the west-east direction, so we placed this in the west-east direction, so it means that because the light was moving perpendicular, all right, it won't be able to pass through the second polarizer or the upper nickel. So, which is why no light will be able to pass through. So, which is why for the cross-polarized light, you'll only see dark. The mineral will appear dark. But this is a different case when we're talking anisotropic minerals. If you haven't yet visited our video on isotropic and isotropic minerals, please, you are more than welcome to look into that. So we know for a fact that because anisotropic minerals, they have got the ability to double refract, or they've got what you call birefringence. Now it means even if no light comes out of the upper nickel, we can still observe birefringence, all right, under XPL for anisotropic minerals, because these minerals they are able to produce two different rays with different velocities. So even if now the second polarizer were to block this light, all right, this one will still be seen, which is why under cross-polarized light, for the anisotropic minerals can still be observed. Now, this nickel, it comes from a French scientist who first built a kind of a prism of calcite made of two halves of the same calcite crystal, adjusting the angles of the prism to a convenient value in order to eliminate all other planes of vibration but one. So we call it a nickel prism. So this was because of the French scientist. But now, in conclusion, the main difference between plane polarized light and cross polarized light lies in their optical setups and the resulting observations. Now, plane polarized light is a single state of polarized light produced by passing unpolarized light through a polarizing filter. All right, and then you'll be able to see the color. All right, which is why under PPL you are able to see the color, but under XPL you are able to see birefringence. Now, cross-polarized light, on the other hand, refers to the setup in which the two polarizing filters are crossed at 90 degrees angles, resulting in a dark field of view. But anisotropic materials show brightness due to the birefringence, the ability to diffract. All right. Now, understanding the optical properties of anisotropic minerals is essential in geological studies, as it aids in mineral identification, rock classification, and the interpretation of geological processes such as metamorphism, deformation, and mineral formation. Thank you guys for joining us today. Your support really means a whole lot to us. Keep supporting us, keep liking, keep commenting, and share the videos. And then, but above all, do not forget to hit the notification button below so that you get notified each time we upload